Welcome back. We are on the topic modular arithmetic. In the previous video, we solved a question on drawing a table for an operation in a given modulus. In this video, we are going to solve a question on drawing a table for an operation in a given modulus when the set of values have been defined for you. The question for this video is: draw a multiplication table for mode 7 on the set 2, 3, 5, 6. So in this question, the set of values that we are going to use in the table have been defined for us. This is quite different from the questions that we have solved in the previous videos. In those questions, we were asked to draw a multiplication or addition table for a particular modulus. So we list the set of values used in that modulus, and then we use that set to draw the table. So for example, if the question had asked us to draw a multiplication table for mode 7, the first thing we would do is that we would define the set of values used in mode 7. The set of values used in mode 7 are 0, 1, 2, 3, 4, 5, 6. Then we will use this set of values to draw the table. After that, we will multiply the numbers in mode 7. This time, the question is asking us to draw a table for mode 7 on the set 2, 3, 5, 6. So the set of numbers that we are supposed to use in the table have been given to us. This means that when you are asked to draw a table for an operation in a given modulus and you are given a set of values in the question, you have to use that set of values to draw the table. So for this question, we are going to use the values in this set to draw the table. We have 4 values in this set: 2, 3, 5, 6. So we are going to draw a table with 5 columns and 5 rows. We are going to draw a multiplication table for mode 7. So the operation is multiplication. You write the multiplication sign in the first cell and then you draw a circle around it. After that, you list the numbers in the first row and the first column. So we have 2, 3, 5, 6, 2, 3, 5, 6. We are going to multiply these numbers in mode 7. So we begin with the first one, 2 times 2. 2 times 2 is 4. 4 in mode 7 is 4. 2 times 3 is 6. 6 in mode 7 is 6. 2 times 5 is 10. 10 in mode 7 is 3. In the previous video, I showed you a simple trick you can use to find the value when the number is bigger than the modulus. I said that you just have to subtract the modulus from the number until you get a value that is smaller than the modulus. So here we will subtract 7 from 10. 10 minus 7 will give us 3. 3 is smaller than the modulus, which is 7. So it means that 10 mod 7 is 3. Let's move on. 2 times 6 is 12. 12 mod 7 is 5. So when you subtract 7 from 12, you are going to get 5. 5 is smaller than the modulus, so 12 mod 7 is 5. Let's move on to the next rule. 3 times 2 is 6. 6 mod 7 is 6. 3 times 3 is 9. 9 mod 7 is 2. So you subtract 7 from 9 and you get 2. And 2 is smaller than the modulus, so 9 mod 7 is 2. 3 times 5 is 15. 15 mod 7 is 1. 15 is bigger than the modulus, which is 7. So you can use the trick that I showed you in the previous video to find 15 mod 7. You subtract 7 from 15. 15 minus 7 will give us 8. 8 is still bigger than the modulus, which is 7. So you subtract 7 from 8 again. 8 minus 7 will give us 1. So 15 mod 7 is 1. Let's move on. We have 3 times 6. 3 times 6 is 18. 18 mod 7 is equal to 4. So you subtract 7 from 18. 18 minus 7 will give us 11. 11 is still not smaller than the modulus, so you subtract 7 from 11 again. So 11 minus 7 will give us 4. It means that 18 mod 7 is 4. Let's move on to the next rule. 5 times 2 will give us 10. 10 mod 7 is 3. You subtract 7 from 10, you get 3. 5 times 3 will give us 15. 15 mod 7 is 1. You subtract 7 from 15, you get 8. Then you subtract 7 from 8, you get 1. So you keep on subtracting until you get a value that is smaller than the modulus. Let's move on. 5 times 5 is 25. 25 mod 7 is 4. You subtract 7 from 25 and you get 18. Then you subtract 7 from 18, you get 11. You subtract 7 from 11 and you get 4. So you keep on subtracting until you get a number that is smaller than the modulus. 25 mod 7 will give us 4. 5 times 6 will give us 30. 30 mod 7 is 2. So once again, you subtract 7 from 30. So we have 30 minus 7, and that will give us 23. You subtract 7 from 23, that will give us 16. You subtract 7 from 16, you have 9. Then you subtract 7 from 9, and you have 2. So it means that 30 mod 7 is 2. Let's move on to the last rule. 6 times 2 will give us 12. 12 mod 7 is 5. You subtract 7 from 12 and you get 5. 5 is smaller than the modulus, so 12 mod 7 is 5. 6 times 3 is 18. You subtract 7 from 18 and you get 11. You subtract 7 from 11, you get 4. So 18 mod 7 is 4. 6 times 5 is 30. 30 mod 7 is 2. And finally, 6 times 6 is 36. 36 mod 7 is 1. You subtract 7 from 36, so you have 36 minus 7, and that will give us 29. You subtract 7 from 29, and that will give us 22. You subtract 7 from 22, that will give us 15. You subtract 7 from 15, you have 8. Then you subtract 7 from 8, and you have 1. So 36 mod 7 is 1. We have now completed our multiplication table for mode 7 on the set 2, 3, 5, 6. Thank you for watching this video. Subscribe to this channel for more videos. In the next video, we are going to solve another question on drawing a table for an operation in a given modulus when the set of values have been defined for you. Bye-bye.